Thanks, Emil, for covering much the same topic that I'm going to cover. This is why they tell you it's always best to go first. No, it's actually good that he spent some time talking about the concept and some of the specific controls, because I'm not really going to talk about that. I'm going to talk more about our journey in trying to actually deliver this as a service in the real world. So we set out to answer a specific question. How can we provide a secure foundation for multiple independent Kubernetes clusters across the enterprise? I think as Amir is right, that the days of being able to funnel everybody to a single centrally managed cluster are probably behind us. And so instead of fighting it, or more accurately, after fighting it and losing, we started out on this journey to see how can we deliver Kubernetes security as a service. So if we're building a service, first thing we need is a customer. Who are going to be our customers, and what use cases of theirs are we actually going to solve? Turns out the customer part is pretty easy. You're building a Kubernetes security service. There's really only one customer you're targeting, and that's your cluster operators. When it comes to the specific use case you're targeting, it became a little more complicated. On the slide here, I've got an abridged list of some of the different cluster use cases that I've come across over the years. Highly abridged. Highly. And since we obviously couldn't do everything, we looked to the 80-20 rule. As it turns out, most developers don't harbor a secret desire to become cluster operators. They really just want somewhere to run their apps. So we found that the vast majority of our use cases can be addressed by that old school, centrally managed multi-tenant cluster for mass consumption, supplemented by individual single-tenant clusters when there's a legitimate use for doing it. Next question is, what do we actually deliver as part of the service? There's no hard or fast rule for what's in and what's out, but a good guiding principle is in the title of this presentation. We tend to favor services that we can build once and use to secure many different clusters without having to customize each one. So what's in falls into three different buckets. First is what I call convenience features. These are the actual Kubernetes bits, templates for secure configuration or secure policy, add-ons like plugins or admission controllers. Basically the building blocks that a cluster operator could use to build their cluster securely. The idea being, if the secure way is the most convenient way, the product largely sells itself. Second bucket is for components that are centrally managed but actually run within the cluster itself. The obvious example is your container runtime security tool. But the other things that I would put in here are your control evidencing, whether it's canary workloads, remote API queries, even good old-fashioned network scanning. Third bucket is for things that live completely outside of the Kubernetes environment. These are things you're probably already delivering as services within the enterprise, centralized logging or single sign-on. What's out? In a word, variation. Custom policies, custom configurations, many different Kubernetes distributions, many different versions, and what I would broadly call non-standard deployment topologies. This is the inevitable request from the development team that really, really needs to run kube on a toaster. The last piece that I would leave out is the managed infrastructure. This is really services where the entire cluster is managed by somebody else, things like Fargate or ACI. And I exclude them not because they're not legitimate deployment models or they don't need to be secured. But if you remember in our first step, we defined our customer as the cluster operator. And for all practical purposes, that role doesn't exist with those products. So we have our customer. We know what services we're going to deliver to them. Next step is to actually build the components of those services. I hope this isn't the part that you've been waiting for, because we're going to rely on magic to assume it's all been built already so we can really focus the discussion around how we deliver them as a service. Presumably not to the toaster, which is a non-standard deployment topology. So what does this look like? There's an easy path and a hard path. Unfortunately, we have to take both of them. The easy path is for those convenience features. Because the deployment is done by the cluster operator, all we really have to do is make sure they know where to find them and know how to use them. And our deployment work is pretty much done. Things get a little harder when we are actually on the hook for operating the service after it's been deployed. And unfortunately, that's where most things fall. This is complex. There are a lot of moving parts. There are a lot of players involved. And so it's worth the time to take the time up front and plan out that end-to-end customer journey. Starting with a service definition. What does the product do? What doesn't it do? Who is it for? How is it consumed? How is it billed? What evidence does it provide? What controls did it satisfy? And so on and so on. This will save you many times over. So take the time to do it. If you've never worked with a service definition before, I suggest picking your favorite AWS product and reading through its documentation. Amazon does a really thorough job of answering all of these questions with its services. So if you're starting from zero, that's where to go. Next step is to automate every step of that process. Start with onboarding, not only to your own services, but quite possibly, if you're repurposing an enterprise service, you may need to automate that onboarding as well. The actual deployment of any components that need to run in the cluster. Policy that will be deployed to and implemented by those components. And yes, even your human processes. As much as we like to talk about the advances we've made in automation, if science fiction has taught me anything, it's that completely automated security response is something we're probably not ready for. Which leaves us with an interesting question. How do you programmatically consume a human process? To find the answer, we look to the service provider world. The specific example that I think works best is the call center outsourcer, in which a single agent may be able to provide phone-based customer service to customers of a dozen different companies on the same day without having to specifically retrain for each one. The way they're able to do this is they have two things. The first is contextual information that tells them what they need to know about the interaction, something as basic as what company the customer thinks they're calling, but also information about the products and customers and anything that's specific to that service. The second thing they have is a set of generalized scripts for common support functions into which that contextual information gets plugged. Sounds a little oversimplified, but fundamentally, that's how incident response works. So how can we take this same model and apply it to our, for the human element, the responders in our Kubernetes security as a service? Well, we'll start with the contextual information. There are lots of potential things you could include in this set, but I think fundamentally you need to be able to answer the questions who's who and what's where. Who are your cluster operators? Where are their clusters deployed? What are their clusters running in terms of components and versions? What workloads are running on them? If you need a concrete example of why this is important, just think back to the last few days as you may have tried to hunt down all of your clusters to make sure that they get patched. The second thing we need are the scripts. And in reality, these are searches, alerts, playbooks, the bread and butter of incident response. To develop them, start same place you would with any application, the threat model. Then apply the 80-20 rule again. The nice thing here is that fundamentally, especially at the platform level, all clouds are the same. They have the same basic components, they function in the same basic way, they interact in the same basic way, which means they also have the same basic threat model. So we can take a generalized threat model for, say, a reference implementation of each of our use cases, right? We have two, the multi-tenant managed cluster and single-tenant standalone cluster. Plug in the contextual information about our specific cluster deployments, and we have the foundation of an incident response process that's reusable across multiple deployments without having to customize it. Now, of course, that's not the end of it. For some workloads, that might be fine. You might imagine, as a bank, we have a lot of workloads with very steep security requirements, and in those cases, we may need to supplement whatever the core service is with something specific to an individual cluster, at least initially. But it provides us a common baseline to build on across our entire universe. The other thing we need to do is make sure that responders are able to go off script, which inevitably they'll have to. And there are two things that we do there. The first is making sure that they get training and experience with Kubernetes. The better they understand it, the better they'll be able to identify and respond to incidents that we may not have anticipated. The second thing is making sure that there's a clear escalation path and always somebody for them to call. Remember, your responders are your customers too. You need to make sure that you give them everything they need in order to do their job. This slide was tough for me. I probably could have done an entire talk just on this one. And I doubt I have enough time to really do it justice here. So what I'll say up front is you're deploying a complex service into a complex environment. Things are bound to go wrong sooner or later, so make it sooner. Test the living daylights out of your service. Test it at build, test it at deploy, test it continuously while it's running. You need to know that it continues to work even as new features are rolled out of your components, new versions of Kubernetes are rolled out. That happens very quickly. And new policies all continue to work, or at least you can have a high confidence that they'll work in different environments. And also you'll start to get a sense for the different ways in which things might go wrong so you can plan for them. The second thing is to instrument your service thoroughly so that you can tell at any given time, and maybe also say to an auditor or another stakeholder how effectively your service is running wherever it's deployed. Lastly, remember, Kubernetes offers a lot of capabilities to help you do both of those things, so use them. Where do you go next? Well, there are lots of options, and really it'll depend on how successful your first iteration was, and what your capacity is, what's really important to you. General rule of thumb that we're trying to follow, at least, is when we scoped the initial release, as I talked through all these slides, there were a lot of every element, we made specific intentional decisions to limit their scope, to keep everything manageable and be able to deliver something end to end. Take one of those elements that you've limited and expand it, just that one element in your next iteration. And then repeat and repeat. And over time, you'll have this built out. As for what we're doing next, I'll let you know when we get there. And finally, some takeaways from this, some do's and don'ts. Don't obstruct. Don't fight it. If there's a legitimate use, a legitimate business reason to use multiple clusters of multiple types within the enterprise, it's harder to secure is not a valid counterargument. Don't chase the tail. As Amir mentioned, find the one size that fits the largest portion of your use cases and save the rest for later. Do focus on your service definition. I can't emphasize this enough. If you don't do this, you will very quickly learn that your customer's creativity is unbounded when it comes to finding ways to use your service that you hadn't intended. Do automate everything. This shouldn't need further explanation. Do build for failure, because it's guaranteed to happen. And finally, don't boil the ocean. Start with a limited scope and gradually and thoughtfully add to it with each subsequent iteration. Are we doing questions? All right. Before we do that, actually, I have to give a shameless plug. We are hiring for our engineering team here in Seattle.
Oh, Oren, come on.
So if you're interested in working on these kinds of problems, please let me know.
All right, I think that's only fair for Oren. First of all, thank you for sharing, everybody. Round of applause. So I do think it's only fair. You agreed to speak at a public event. We'll let you recruit at the public event.
That's how we justify it.
Okay, here's a quick question.
So this is a question that doesn't fit well at a KubeCon or KubeSec, but in the kind of hammer nail scenario, Nomad. It seems to me that we've gone Kubernetes crazy, and for some of the things that these edge simple things, I find a lot of my customers are just throwing up Nomad, and it's just simpler. You don't fight the battles of all the things you do. I'm just wondering if that's something you've thought about, and I'm pro Kubernetes, so it's not like and I don't work for HashiCorp. So those are two get out of the way things, but I wonder what your thoughts are.
Yeah, absolutely. I mean, we could have had the same conversation about even different deployment models of Kubernetes. Whether you're running it yourself or using commercial distribution, or you're deploying it in the cloud, which model. There's always going to be that kind of variation. Some things, we try to strike a good balance between not being completely and tightly coupled with any particular technology or deployment model, but at the same time, when you have you go where the customers are, and if everything is converging around Kubernetes, yes, it's worthwhile to advocate whatever the right solution to the problem is, but at the same time, there's also the problem that's in front of us that we need to solve. So there's no easy answer.
Do we have another question? Take one more here. Wow, okay. Oh, we do, okay.
Ooh.
So how do you deal with lately vendors are giving people container images to run instead of where they used to use soft appliances? We're having that, it's a huge problem, and we didn't initially think that was going to be a use case, and here a year later, we're like, what? Why? And they're horrible images. They're usually, especially data science companies, sorry, if you work for a data science company, sorry.
It is not limited to any specific industry.
But we get like, we got recently an 8.5 gigabyte image, or certain network vendors, part of an automation solution they want to deliver, they're giving us containers, and we have basic rules. You can't, anything that scores 7 and above, you can't run. You can't have SSHD, you can't have Netcat. You have Netcat in your image. No, we don't. Yes, you do. I mean, what do you do with that?
For the record, our biggest image is 22 gigs. Anyone have that beat?
Recently came out with something. Are you trying to make those images smaller by compacting them?
I really hope they reconceive the way they use images. But
okay.
To your point, most of the vendors won't. And so I consider that lift and shift. So that falls under one of the tenancy models that I talked about on the what customers are we going to support slide. And frankly, my position is you would have run that software on a server. Now you have it as a container, run it in Docker on a server. This does not belong in Kubernetes. Not unless it's, what I'll say is we won't go out of our way or make compromises in the design of a Kubernetes platform just to support a workload that is being lifted and shifted and just happens to be running in container format. Sort of. It's evolving. It's evolving. We've got a lot of these that are in the pipeline, not necessarily in production yet. Ironically, the Kubernetes model is more advanced than the standalone Docker.
All right, well, great. Thank you once again, Oren. Round of applause for your presentation.